This is problem 14.1. It's on page 598. A 50,000-ton ocean liner has an initial velocity of 3 miles per hour. Neglecting the frictional resistance of the water, determine the time required to bring the liner to rest by using a single tugboat which exerts a constant force of 45 kips. Of course, 45 kips would be 45,000 pounds force. So let's write down what we're given. First of all, this is chapter 14, problem 1. The weight of the ocean liner is 50,000 tons. Now technically tons are a measure of mass, so it really should be 50,000 tons of mass, but anyway, we'll take care of that later. The initial velocity is 3 miles per hour, and the force from the tugboat is 45,000 pounds force. So we want to know the amount of time to take the velocity, let's do it this way. The amount of time to take the velocity to 0 is really our question. The solution will be to use the momentum balance, and the momentum balance says that the initial momentum plus the impulse of external forces acting on the body equals the final momentum. Of course, we know the final momentum is 0 because the final velocity is 0. So basically what we know is that the momentum, the initial momentum, must be balanced by the impulse of the tugboat force. Now the tugboat force is applied at the same constant amount, and so the force will come out of the integral, and what we'll end up with is negative F delta t, where we're just integrating time, or adding up time, and so we just get however much time it requires to completely eliminate all of this momentum. So the amount of time required then is negative mv naught over F, so it's just the ratio of the initial momentum to the force. And so if we plug in the numbers here, the mass, if we were to calculate mass from this, there's 2,000 pounds mass per ton. So let's see, we'd have to, well, let's just plug it in. There's 50,000 tons multiplied by 2,000 pound mass per ton, multiplied by the initial velocity of 3 miles per hour. I'm out of space, so I'll have to put the conversion factor for the miles and hours in the denominator, but that's pretty straightforward. There's 1 mile per 5280 feet, and of course, let's see, we'll want 3,600 seconds per hour. That way the hours go away, the miles go away, and the tons go away. We'll be left so far with, let's see, that would be foot-pound mass per second. So then we have to divide by force. Now be careful. The momentum balance, or this momentum equation, is a vector equation, so you have to take into account the direction. Now the direction of the velocity will be opposite the direction of the force. That's why we ended up with a minus sign here. Because if the velocity is in the positive direction, the force is going to be in the negative direction. So what we need to do is plug in the force, but the force is actually a negative 45,000 pounds being applied to the boat. So let's see. So 45,000, let me not forget the negative sign, pound force. Now if you look at this, you'll notice that we've got pound mass foot per second per pound force. Now let's see, that won't work, right? Because a pound mass and a pound force are two totally different things, so we need G sub c. I'm running out of space, I apologize. Let me grab some space over here and add to the denominator. Let's see, so I need 1 pound force per 32.2 pound mass foot per second squared. Okay, hopefully that's understandable. So then, you know what, I messed up because this is pound force, this is pound force. I need the inverse of that conversion factor. So let me try again. Let's see, 32.2 pound mass foot per second squared per pound force. Now the pound force will cross off, and so will the pound mass. The foot will cross off, and one of the seconds cross off. So it's hard to read, but these seconds are in the denominator of the denominator, so they are the units of time, seconds. Notice all the other units are gone. Anyway, plug all of this into your calculator, and delta t, the amount of time required to slow down this boat, is 303.66 seconds. Now, of course, that's not a real convenient unit, so I converted it to minutes, and it's a little over 5 minutes that it takes to slow down this ocean liner.